In this tutorial, we're going to continue learning how we add vectors. In this situation, we're going to add vectors that are not at a 90-degree angle. In this problem, we have, on a scavenger hunt, Jake walked the following path, and we want to find his displacement, and because the displacement is a vector, we need to find the direction, meaning the angle as well. So Jake walks 5 yards north, turns at a 55-degree angle, walks 3 yards more, turns east and walks 1 yard, and then turns north to walk 12 yards. Now what we want to do is we actually want to turn this into a problem where we find a hypotenuse of a right triangle. So we're going to find the total distance Jake walked east and the total distance Jake walked north, and then turn that into a right triangle. Okay, so if I can illustrate here, we're going to find how far east he has walked, how far north he has walked, and then we'll turn this into a right triangle because that's what we know how to do. We're going to start by looking one vector at a time. The first vector, I'm going to redraw this. Jake went 5 yards north. I'm going to find the x and the y components. Now, when you have a vector that has no angle, one of the components will always be 0. Remember that the x component is how far horizontally we have moved, left and right. And Jake has not moved left or right at all in this section. So it is the x component that is 0. The y component is how far north or south, up or down Jake has moved. And in this case, Jake has moved 5 yards north. Now I'm going to draw an arrow here to help me on in a later step. The next part here of Jake's trip is that he goes 3 yards and he's going to go at a 55-degree angle. And we're going to find the x component and the y component. To do so, we're going to have to do our vector resolution. And so first, I'm going to label the sides. My hypotenuse is the longest side, so that's the 3. The 55 degrees is at the bottom. So the opposite of bottom is top. Therefore, my x component is the opposite. And the adjacent side is the one touching the angle, but is not the hypotenuse. To find the x and y component, I'm going to use my SOHCAHTOA. Let's find the x component first. The x component is the opposite side, and I have my hypotenuse, so that is the sine. I'll write some scratch work down here. The sine of 55 degrees is equal to my opposite x over my hypotenuse 3. Now again, I need to figure out what number this 55 is. So I can either type it in my calculator, or I can look it up on my trig table. 55 degrees, and the opposite, or the sine, sorry, the sine is the first column. The sine is the 0.819. I multiply each side by 3, and I get my x component to be 2.46. That is east, that Jake has traveled during this part. To get the y component, I'm going to use my adjacent and my hypotenuse as the cosine. Adjacent over hypotenuse. I have to look up what the cosine of 55 is. I need to type it in my calculator, look it up. The cosine is 0.574. We round it off. Again, I multiply by 3 on each side, and I get my y component comes out to be 1.72. And Jake has moved north during that section. Okay, continuing on, I have two more vectors that I have to write down for. But these vectors here are actually going to be a little easier because there's no angles involved. So the next one is 1 yard east. My x component, in this case, is 1 yard. That's how far he moved left or right. And the y component, how far he moved up or down, well, he did not move up or down at all. So the y component is 0. The last one is 12 yards north. Again, my x component, my y component. The x component is how far he's moved left or right. He hasn't moved any left or right during this section. And the y is the up and down. He has moved up 12 yards. Now the next step in this problem is we are going to look at all the x's and add them together. We want to know how far to the east Jake has gone during this section during the entire trip. So how far has Jake gone east from where he started? So we're going to add up all the x's. I'm going to give you a notation here to show you a shorthand way of writing adding up all the x's. If I want to take the sum of all the x's, I use a Greek letter called sigma. Looks kind of like an E. That is the sum of all the x's. So if I look at my x's, I have 0 plus 2.46 plus 1 plus 0. Now, if they're all in the same direction, we add them. If any of them would be backwards or to the left, then you'd have to subtract those to get the total. We don't have any of those this time. So we're going to take the total of 0 plus 2.46 plus 1 plus 0, which is 3.46 yards to the east. And now we're going to do the same thing with the y components, the total up and down. So the y components are 5 up, 1.72 up, 0, and 12 up. So again, what we're trying to find is how far north Jake is from where he started. So this part down here is 3.46. Now, how big is this section here? So again, we're going to take 5 plus 1.72 plus 0 plus 12. That comes out to be 18.72. And now that we know those numbers, we want to find the hypotenuse and the angle. I like to rewrite this triangle though. So I'm going to rewrite this. We know that Jake has gone east 3.46 yards, and he has gone north 18.72 yards. We want to find the hypotenuse and the angle. And we do so the same as what we did in the very first video. We find the hypotenuse using the Pythagorean theorem. The hypotenuse squared is equal to 3.46 squared plus 18.72 squared. Again, if I take 3.46 squared plus 18.72 squared, I get 350.5. But that is d squared. So to answer for what is d, we have to take the square root of each side to undo that square. And when we do so, we get 19.0 yards. That is only half of the answer. We also need the angle. And to get the angle, we take the inverse tangent, because we have the opposite and the adjacent. Opposite side, adjacent side. We take 18.72, the opposite, over the adjacent, 3.46. And when I take that ratio, I get 5.41. Now again, you can type this in your calculator if your calculator can do inverse tangents. Otherwise, you have to look on your trig table for a number in the tangent column as close to 5.41 as you can. And if I look at my tangent column, here we have 1.7, 2.6, we have 5.1, and then we have 5.6. So it's somewhere between 79 and 80. And 5.4 might seem a little bit closer to 5.6 than 5.1. So we're going to go with 80 degrees here. Again, if you type this in your calculator, you get 79.5. So we just have to round off if we're using the trig table. But if you have one of those calculators with sine, cosine, tangent, by all means, put your answer down as 79.5.